Hello, today I'm here to talk about how time travel debugging allows you to capture and diagnose failures with a single build and test cycle of your application. Let's start by building and recording the execution of an example application that ships with Undo's live recorder. As you may have guessed from the name, the deadlock application deadlocks, so we need to stop the application and recording with Ctrl-C. And we can see we have the binary, the recording, and the original source code in the file system. Now we have the recording, let's move to VS Code where we can start diagnosing it. As you can see, I have the source code open, so let's select Replay a Live Recorder recording and replay the recording we just created. Let's make a little more space for the source code. But we can see that we stopped recording while the main thread was at pthread join, waiting for the other threads to finish. As you can see, we initialize some data and then we spawn off two threads to run the tester function. So let's have a look at that. So tester looks like it's going to loop around 1,000 times. Each time it's going to switch based on a random number, mod 2, which means it can be 0 or 1. And we're only testing add and remove, so the case 2 never hits. So let's add a log point to the add case. We can use $TID to get the thread ID, as we have two threads running this. And we can use the curly braces to extract the value of the iters variable and see the iteration count. We'll do the same with the remove case. As you can see on the right, because we have a recording of this application, we have been able to effectively add additional logging statements into the code without having to rebuild and retest to generate this additional debug log output. So with this additional log output, we can see the two threads and we can see them iterating. Ultimately, we see each thread stalls in the add case. So let's have a look at the function inside the add. As this application is deadlocking, it's interesting that we have a lock and unlock function here. Let's go into them and add some additional log points to see how they're used. Let's just use the pointer to the list to differentiate between multiple lists. We can see that we're locking this list that ends 78 and unlocking it. We're then locking it again. Okay, we then go to lock and unlock the other list that ends 40 afterwards. And then we're trying to lock 78 again, but we've already locked 78. It's the same thread, the await thread. So we've locked it twice, and that's why that one's deadlocked, because we didn't unlock it first. And we can see that the other thread is just straight up locking the first list and then locking it again. So let's look at the first time we locked that and click on this so we can go to that point in the history. Although it's not immediately obvious, we've moved to that point in time. So let's step forward so we can come out of this lock function, having locked the list. And here we are in the unlinked. This was the remove. This is where we expect to be this time. Let's step through again and we can see that we're stepping and we've got to return null. So if we look at the code here, we've locked the list, but we've returned from the function without unlocking it. At the end, we would normally unlock it. So we've diagnosed the root cause for our deadlock. We should be unlocking the list before we return in the remove function. Hopefully you can see how by using recordings, I've been able to avoid having to run multiple build and test cycles with different instrumented versions of my code to provide additional log files. This is just one of the ways you can use recording and time travel debugging to capture and diagnose issues far faster than you would normally. Thank you.